Hello kids, let's start with our science subject chapter 18, sound, production of sound. Let us begin. Can you see over here in the picture, variety of events generating sound. It is different when you clap, when the crackers burst, or when you play instrument. It is seen from the above examples that sound is generated due to a variety of events. In some examples, sound was generated due to the vibration of an object. For example, the bell or the strings of diaphragm of a musical instrument. While in some examples like bursting a cracker, clapping, a lightning strike, vibration are not actually felt. However, vibrations are produced in those cases as well. All these vibrations are imparted to the molecules in the air and sound is produced. You might have seen that when a stone is thrown into the calm water of a lake, waves are generated and they reach up to the banks of the lake. Vibrations reach our ears through the air in a similar way and the sound is heard. You have learned how sound is generated, how it reaches us on traveling through some medium and is heard by us. You have also seen that vibration of an object is necessary for generation of sound. In the present lesson, we will learn more about vibration, pitch, intensity and level of sound. When the string of a musical instrument such as tanpura is plucked, the string can be seen to vibrate, but the two ends of the vibrating string are still. As it vibrates, the string moves to one side of the central position and comes back to the central position. This motion of the string is repeated again and again at fixed intervals of time. Such motion is called periodic motion. Let us see about oscillator, oscillation and oscillatory motion. You must have seen children playing on a swing in a garden. Observe carefully the motion of the swing. Go to a swing at rest in a garden and mark its position on the ground below it. You can call this mark the central position of the swing. Now pull the swing to one side and let it go. Observe how it swings. The swing will be seen to cross the central position again and again as it moves from one end to the other of its swing. A swing that moves back and forth like this is an oscillator. When the swing moves from one end to the other and returns to its starting point, it is said to have completed one oscillation. The back and forth motion of an oscillator on either side of a central position is called oscillatory motion. Take an empty porcelain bowl or an empty steel glass. Stretch a rubber band and fix it on the bowl or glass as shown in the picture. Now give a jerk to the rubber band. Repeat this action applying a smaller or greater force. While doing this, observe the farthest distance to which the rubber band is stretched. Take note to the sound generated. When the rubber band is stretched and released, it vibrates. Compare the vibration with the figure alongside. When the rubber is stretched from the original position A and comes to position B, it is seen to be curved. The maximum distance between the original position A and the position B on stretching the rubber is called the amplitude of vibration. When a greater force is applied to the rubber, it is stretched further, meaning that the amplitude increases. On releasing it, a louder sound is generated. When a smaller force is applied, the rubber is stretched less. Then the amplitude is smaller and the sound is softer too. Take a strong thread about half a meter long. Tie a small iron or a wooden ball to it and suspend it from a support as shown in the figure. Such an oscillator is called a pendulum. Give an oscillatory motion to the pendulum. Oscillator, oscillation and oscillatory motion. The maximum distance between the original position A of the pendulum and the extreme position B or C is called the amplitude of oscillation. In the figure, AB or AC is the amplitude of oscillation. Time period of oscillation. The time required by an oscillator to complete one oscillation is called the time period of the oscillator. In the previous activity, the oscillator transfers the distance from the extreme position B to the central position A and from there to the position C. then back again to A and from A to B. The time required by the oscillator to traverse this distance BA-CAB is the time period of oscillation T of the oscillator. Frequency. The number of oscillation completed by an oscillator in 1 second is called the frequency of oscillation. The total motion BA-CAB is one oscillation. Frequency N is equal to I upon time period of oscillation T is equal to I upon T. Frequency is the number of oscillation occurring in 1 second. The unit of frequency is Hertz. 1 Hertz means there is 1 oscillation in 1 second. 100 Hertz means 100 oscillation in 1 second. Take a plastic ruler and hold one of its ends pressed down on the table as shown in the picture, so that a large portion of the ruler is off the table. Now ask your friend to press the free end of the ruler down and release it. Observe what happens. Now press the ruler with your finger at such a point that it stops making any sound. Now pull in 10 cm more of the ruler out of the table and repeat the action. Listen to the difference in the first and the second sound. Take note of the difference in the frequency and pitch to the sound. Also take note of what happens by further decreasing the length of the free part of the ruler little by little. Explain what is meant by low frequency and high frequency. A low frequency sound has a low pitch like the rumble of a big truck. A high frequency sound has a high pitch like a whistle or siren. In speech, women have higher fundamental frequency than men. High and low pitch of sound. Take a wooden board 80 to 90 cm long and 5 cm wide. Hammer 2 nails into it, each a few centimeters away from its 2 ends. Tie the ends of a thin metal wire to the nails so that the wire is stretched tightly between them. Insert a wedge-shaped wooden or plastic block under the wire near each of the nails and plug the wire lightly. Did you hear any sound? Observe whether the wire vibrates. Now insert 2 or 3 small rectangular blocks below the wedge-shaped block on one side in such a way that the length of the wire does not change. Observe whether there is any change in the tension in the wire. Now plug the wire with your finger and listen to the sound. Also watch its vibration. Note the difference you perceive in its frequency. What can you infer from this? When tension in the wire is increased, the frequency is seen to increase, and when it is reduced, frequency is also seen to reduce, that is decrease. We also perceive a difference in the sounds generated. When the tension is increased, the resulting sound is shriller. When the tension is reduced, the sound is also less shrill. This is what called as the high and the low pitch of sound. Which of the sounds, the roar of a lion or the hum of a mosquito, has the higher pitch? Yes, the roar of a lion is higher. Now, what structure in the sitar help to produce higher or lower pitched sound? Yes, the answer is the string of sitar help to produce higher or lower pitch sound. Intensity of sound, sound level. Loudness or softness of sound is indicated by two terms, namely intensity of sound and sound level. Sound level is the intensity of sound as perceived by our ears. The intensity of sound is proportional to the square of the amplitude of vibration. For example, if the amplitude is double, the intensity of sound becomes 4 times as much. Audible sound. The frequency of the sound audible to human being is between 20 Hz and 20,000 Hz. We can only hear sound in this frequency range. Now, what is infrasonic sound? Have you ever heard the sound of the movement of our hands or of the movement of leaves falling from a tree? No, that is not possible. Take oscillatory and swing an oscillator which makes 3-4 oscillation in a second and listen carefully for any sound it makes. That the oscillator makes 3 to 4 oscillation in 1 second means that the frequency of the sound is 3 to 4 Hz. Now, human cannot hear sounds of frequency less than 20 Hz. In all the above examples, oscillation did take place but no sound was heard. It means that this sound is of a frequency less than 20 Hz. A sound with a frequency less than 20 Hz is called infrasonic sound. Sounds with a frequency less than 20 Hz are produced by some animals, namely whales, elephants, and rhinoceros. Ultrasonic sound. A sound with a frequency higher than 20,000 Hz is called ultrasonic sound. Human beings cannot hear such sounds. However, animals, for example, like dog, whales, they make such sounds. Ultrasonic sound you can see in the red. Audible sound you can see in the green, and that is what infrasound, less than 20 Hz. Audible is between 20 Hz to 20,000 Hz, and ultrasonic sound is more than 20,000 Hz.